In question 5 here, we're asked to write the scalar equation of each plane, and in part B, we're told that the plane is perpendicular to the xz plane with a z-intercept of -1. So the key to this question is just figuring out, trying to interpret the given information here. So the easiest part to interpret is the z-intercept of -1. They're just giving us a point that is on our plane, and that point is x equals 0, y equals 0, and z equals -1. That's where it intersects the that z-axis. Okay, so x and y are both 0. Now, what about this information perpendicular to the xz plane? Well, that's a little trickier because there's two possibilities here. We could have, I'll just draw like a little three-dimensional coordinate axis here. So this is x, this is y, this is z. So our xz plane, you can see, is kind of, you can imagine it coming out of the screen here, sort of horizontally. If we want something that is perpendicular to that, we have two options. We can have something that is parallel to the xy plane, so that would sort of be like this, sort of in the plane of the screen, or we could have something that is in the yz, or parallel to the yz plane. Okay, and maybe I'll just redraw that over here. Sorry, x, y, and z. So again, if our xz plane is horizontal, coming straight out of the screen here, another plane that is perpendicular to it is something parallel to the yz plane, which would be kind of along here like this. Okay, you can imagine it containing sort of both the z and the y axes. Now, which of these two options do we want? Well, we're told that this plane that we're interested in has a z-intercept. So that means that it has to intersect that z-axis at only one point. So if you look at this plane that I've tried to sketch out over here on the right-hand side, the blue one here, if we imagine we've got this plane here, it's either going to contain the z-axis, okay, if we make it right there in with the yz plane, or if we shift it sort of to the left or to the right, it's going to be parallel to that z-axis. So it's either going to intersect that z-axis at multiple points or not at all. So that's not the one that we're interested in. We're interested in the one over here on the right, the red plane here, which is parallel to the yz plane, and again perpendicular to the xz plane. Parallel to the xy plane, right, vertically like that. So if we're going to get our scalar equation, we need a normal. So the easiest normal vector to use for something that looks like this red plane here is a vector that points along the z-axis. So we can use 0, 0, 1 as our normal. And then once we've got that figured out, it's pretty easy to find the scalar equation of the plane here. We know that they've given us a, b, and c here, so those parameters. So it's going to be like 0 x plus 0y plus 1z plus d equals 0. And we have this point that we can put in, which is 0, 0, -1. So that's a whole lot of zeros. So we end up with d equals 1. So our scalar equation here is going to be just z plus 1 equals 0.